because we'll use those as well. Pretty much the ones that are highlighted are the ones that we have a shot of using in the class. And this is a good time for me to stress the importance of this. You've got to learn your elements now. Remember when I told you things will come up in this class that will bite you in the butt? This is starting you down the path. If you don't learn the elements, you're not going to learn your bonds well. You don't learn your bonds well, you can't learn the nomenclature. If you can't learn the nomenclature, you can't learn the chemical reactions. You can't do the chemical reactions, you can't do the stoichiometry. You can't do the stoichiometry, you're in a whole lot of trouble.
Geometry. Can I have another one?
Sure, I have plenty.
See, I told you
No. In my opinion, hardest thing you're going to do is stoichiometry because I combine it all together. This is literally the first step in building our skyscraper, ladies and gentlemen. And I say skyscraper because you know how everyone's like, you build a foundation, then you build it up. That's like what we keep doing. We build a foundation, build it up, oop, new foundation, build it up, oop, new foundation, build it up, and we just keep going.
We're more like the Leaning Tower of Hazel with this stuff.
No, we ain't leaning.
Are we going to have to put these in
We're like
order?
falling.
No.
No.
I need you to know. This is the reason as to why I need you to know. So if I give you something like...
So what do we
If I give you something like SrCl2, I don't need you digging through a periodic table to find what those are. I need you to look and go, strontium chloride. This is very simplistic nomenclature.
Okay.
Now, to answer the question that's going around in your minds, and I heard one of you ask, this is not your quiz on next Friday. Next Friday, this is fair game to be on that quiz,
That's true.
but next Friday is what you've learned in the class. On Tuesday,
It's a blank quiz means nothing on it.
on Tuesday, you will come in here and I will give you the 50 element quiz.
Okay.
Understand,
Too much. I'm ready.
that's the only thing that's going to be on that quiz.
What Tuesday?
I'm good. Next Friday.
Next Friday. This Friday is a lab. This lab will be the most
Fun.
thought processed out lab you've ever done in your life.
Well, the people who are missing it.
So then this will
So this coming Tuesday?
This coming Tuesday. The next Tuesday, we're in this room.
Wow.
Unless a snowstorm happens, and then it's like, school gets canceled on
Somebody
Tuesday.
leaves a couple of lights and throws it in the road, we can't get down here.
Wait, which gives me a good point, like brings up a good thought. Okay, look, if I assign something to you, so like your quiz is on Tuesday, if we have school on Monday, your quiz is Tuesday. If school gets canceled on Tuesday, and you come to school on Wednesday, you're having the quiz. Then you have the quiz Thursday. Go back like work.
So what if we
We
don't have
come,
school
but
on
you
Monday?
don't, because you said we'd never have a quiz or anything while you're gone.
Wednesday, but it's Thursday.
And we already have those, so you've already broke that rule.
No, I was here.
Oh yeah, you're the principal.
But you weren't here. Daggone it.
So,
Well, let's say you aren't here, then would we still have to take it?
I'm gonna do that.
What if you become deathly ill?
It didn't work.
and the farthest thing off my mind is y'all.
I wonder if people actually do that.
I'm have to try.
Okay,
I'm not done highlighting.
I hope next year's the biggest snowstorm.
all right. So we're gonna get into this, and we're gonna start talking about something that honestly I kind of enjoyed a little bit. It's a little bit of a thought process. This is going to help you out later on in the class and be able to explain things to you later on. Remember how I told you there is reasons why we have for every element to sit where it sits? This is why we got those reasons, okay? We have the trends of the periodic table. This goes with every note you took in this class. Remember, once you learn it, don't forget it. Oh, what?
Usually we do forget it.
Alright, so anyways, we got different things we're going to talk about, okay? Different trends. And I'm going to hit this up and give it to you. I'm going to give a definition like what a book will give you, and then I'm going to write down like a definition that I'll give you. Okay, it makes it simplistic, in my opinion, to where you can understand it better. So the first example of this is the first trend we're going to talk about is atomic radius. So atomic radius is 1/2 the distance between the nuclei of identical atoms that are bonded together. So half the distance between identical atoms of the same element. We are recording this so that you guys can have this to refer back to. I made it through second period without cracking and going through puberty.
Now for the quick commercial break.
So in this is what we're talking about is like if we had two atoms like here, these two atoms, we'd split them in half. And half the distance between these two. So that'd give you the radius. That's all we're saying. Let's see. Let's do blue, red. All right, so there's your first trend. Moving on to the second trend. It's one of my favorite because what it's all about. This one is ionization energy. Ionization. What?
How do you get chestnut?
Same chestnut.
That says element. I'll worry about her.
It's those Christmas trees.
Does that say chestnut?
It does look like chestnut.
It kind of does look like chestnut from
Out of what?
Because like the Aton chestnut.
All right, I love y'all greatly, but y'all definitely need some glasses.
I have contacts.
Y'all need an updated prescription. All right, ionization energy is the amount of energy required to remove one electron from a neutral atom of an element. Ionization energy is the energy needed to remove an electron from a neutral atom. Hey, are y'all going to make it back here? Sweet goodness. Treason?
I love
It's like
Christmas.
going against the country. I don't know. Science teacher asked the social studies teacher.
Like when people say you've been like,
You've committed treason.
Wyatt Harvey to the office, please.
All right.
Addie.
From here, we go to the electron affinity.
Affinity.
Affinity. Oh, it's supposed to be.
glaring.
Electron affinity is the energy change that occurs when an electron is acquired by a neutral atom. All this is the change, the energy change in an atom by a neutral atom gaining an electron.
Mr. Hall,
What?
I'm going to go TikTok famous.
Cool.
Y'all want to ask me on what on?
Sure, what on Amy?
Okay, well, you,
Tell him to follow you.
well, you gave me a bright idea that, okay, so, you know how people think that science made the earth and not Jesus? You know, okay, well, you know how we have like Adam and Eve in the Bible, but in science you just have atoms? Well, it's like Adam and atoms.
Here's Adam, here's Eve. That's what she's saying.
It's all just tied together.
Say what?
It makes sense in our
Saying
mind.
Eve
It makes sense in our minds, but
He looks worried.
A little bit. Alright, here comes the next one. This is the big one. I will openly look at you and tell you, this is the one that you will use very quickly, okay? Electronegativity. Electronegativity is a measure of the ability of an atom in a chemical compound to attract electrons from another atom in the compound. My definition, the ability
Are these going to be on the test? It's fair game. So this is trash.
wait.
the ability of an atom to attract / pull on another atom's electron. Atoms like, it owns it, so apostrophe S. There's your English for today.
Can you explain or tell me how you spell that? Copper.
E. Electronegativity. E-L-E-C-T-R-O-N
Can you give us the part of speech of that word?
A-T-I-V-I-T-Y. Electronegativity.
Negative.
Tiv. Tiv, not div. Tiv.
Mr. Hall, have you ever realized that Adam ends up making the Star of David on it?
Whoa.
Everyone.
Dang.
Had a student made that for me, so I kept it. Josh Stacy. Like old country Josh Stacy, like firefighter Josh Stacy. That Josh Stacy. No. Yeah, that's why I said firefighter Josh Stacy. Alright, in this is the thing. You guys have used these before. You didn't use these before, you haven't used them before, but now you're going to learn about them, okay? Because pretty much everything we're talking about here is going to reflect back to these guys. And I highly recommend listening right now, because if there's every rule in this class that you're going to want to know, that you're going to hear thrown back at you 1,500 times in this class, it is this rule.
It's in purple.
Valence.
Valence electron.
That entered
Valence.
Valence. That's an N. This is the number of electrons in the outermost energy cell. Pretty much, you don't make it any simpler than that. The electrons in the outermost energy level.
I wish we could go back to what we were doing.
There is a trend to follow with this. You guys will learn there's a trend in here, since we're talking about trends. You get to something, you think it's hard, and then you get to the next thing, you're like, oh God, that was easy, let me go back.
Can I have that SpongeBob?
Oh,
What happens if we buy another one?
then you bought a SpongeBob.
No, we want the, oh, yeah, we can buy the bridge.
You bought Grinch.
Replaced it.
You have, you know how on iCarly, he makes the TV cartoon thing out of the,
Yes.
we should make one in here with SpongeBob. Yeah. See, I mean, we have a video camera.
All right. There is a trend that goes with this, okay, with these valence electrons. You need to learn this. You need to know this. Whenever we're talking about valence electrons, first thing, the D block,
Well, that's a nice drawing.
and the F block
Look, a fish.
I would like to tell them.
do not matter.
Ooh.
So should we wrap?
Oh, they don't matter. They don't
Okay.
matter.
They don't matter because they have different rules. We'll talk about it later on. D block we'll talk about whenever we go through the metallic bonds. We'll talk all about it. They're very special dudes. They do very weird things. But it gives us the ability to have everything that we have. Literally the ability to charge your devices, to have the light in this room. For me, to have this view board working is all because of the basics within metallic bonding.
Yep.
So they don't matter as valence electrons?
In terms of valence electrons, they do not matter because every one of them have a different number. Well, not every one of them, but they flux. Different ones can have different ones. D and F don't matter for valence electrons. The ones that matter are S and P. I'm going to teach you the trick to figure out how many valence electrons there is. And it's based off the columns. First column, this is only for valence electrons, okay? This is for determine how many valence electrons there are. I can't stress this enough. First column for the valence electrons is 1. Everything in column 2 has 2 valence electrons.
Valence electrons is the whole D block.
Yeah.
I'm being serious.
Well, pay attention.
I was.
No, you weren't. You were sitting there talking, laughing, giggling like you had the whole class.
I have not. Okay. Valence.
I stressed 1,300 times. D and F block don't matter. Only the S and the P block matter.
That's why he drew a fish.
First column has 1 valence electron. Everything in the second column has 2 valence electrons. Columns 3 through 12 do not matter because it's D block. Go to column 13. In column 13, 3 valence electrons. 14 is 4 valence electrons. 15, what do you think? 5. What about for 16? 17?
7.
18? 8.
Should we write that on this?
You can.
Or a different one?
You can write on whichever one you want. I'll give you like, what, 30 now?
Yeah.
We have to remember that.
I'll put it on the one with the.
Oh, it's fair game. We need the black kid on the website where if somebody asks a question, he presses the button, then all of everything falls. A big fan.
Okay. So moving off of that, those valence electrons. Those are the key in knowing those, alright? They literally give us the abilities of what we're looking for. So, moving into this, let's talk about atomic radius, or atomic radii first. We're going to talk about the trend for it. In this, you're always talking in terms of columns and rows, okay? So first thing we'll do is we'll talk about columns. The atomic radius, as we go bottom to top of a column, will always decrease.
So the column goes up, it decreases.
As you go up a column, it decreases. Which means as you go down the column, does it increase or decrease?
Increase.
Increase. Okay.
Okay, can I ask a question?
Tell you why in a second.
What exactly do you mean by that when it goes up? Like,
Okay, in terms of sodium or lithium, which one's larger?
oh. Okay, I understand now. So, like, if you were at potassium, it is larger than sodium. Is
Yeah.
that what you mean?
Exactly. What's up?
You don't have a cell model, do you?
Your what?
My cell model.
Oh, it's gone.
I had a final 2 on the 12.
Yeah.
That's my last final. And I was like, I think it's still model, and that's your final. I was like, they probably still has mine because they did last year. And of course, you can't.
I did. Fire marshal was coming through, and it was above the 18-inch rule. And this new fire marshal was like down. He was like hardcore.
Was it a human cell model? I don't remember. What the?
Well, you do fine. Ain't gonna take you no time.
I know, but still, I didn't want to do it all. You had it. What
Alright.
is this, chemistry?
It is.
Pay attention to conversions, because if you go to nursing, you have to have it. Drug and dosage calculation testimony.
Later. All right. So in this, why does it decrease as we go up, or why is it increasing as we go down? This is as to why. What happens as we go down the periodic table? What are we adding?
Atomic.
You are adding atomic number. Go back to referring back to the principal quantum number. What did the principal quantum number show us? What did it tell us? We always found this by looking at the row. It's 2 words. First word is energy.
Energy level.
Energy levels. So, as you go down, you add energy levels. Remember whenever we did this, based off of these energy levels, literally, as you go down, first row, first energy level, second row, second energy level, third row,
That makes a lot.
third energy level. As you're going down, you're adding energy levels, which makes it get bigger. So it increases.
Why didn't you tell us this when we done it?
You probably did. We didn't.
So as you go up the column, it'll decrease. Why? Because
So does this go with ionization or?
atomic radius.
As you up.
This still stays with atomic radius. I do that as an example.
Okay.
As you go up column, you lose energy levels. Go down column, you gain energy levels. Thought bubble. Being able to explain as to why. You what?
That's what I asked you.
What is it?
I think it's like
No. This goes with atomic radius.
So I was trying to ask you.
Sorry.
Oh,
Speak with confidence. Speak loud.
I did, and you said, hold on, I'll answer you in a minute.
It's probably when I was getting 3 questions. All right, in this, as we go left to right on the periodic table, so left to right on row, atomic radius will decrease.
If you go right, it will decrease.
As you go to the right, it decreases.
Why is that? I thought it was increase.
Good thought, but this is as to why. Think about it. As we go left to right on the periodic table, what are we adding? So, like, you literally go from sodium to magnesium. What's the big difference between sodium and magnesium? 11 and 12. So what's the difference? What did we add? What's been added to change?
An atomic number.
The atomic number, which represents proton. Protons. So, in this case, as we go left to right, we're adding protons. Well, what are protons? Positively charged subatomic particles. Y'all guys are doing so great. You're remembering everything I've taught you.
Okay, you didn't have to be that dramatic, Mr.
I missed that today.
That's why we have.
So we're adding protons, these positively charged subatomic particles. What are electrons?
Negative.
Negatively charged electrons.
Subatomic particles. So what happens with a positive charge and a negative charge?
Negative.
They are attracted. They come together. So if I add more positive charges, will it pull it closer or just let it go farther away? It'll pull it closer. So why does it decrease as we go left to right? because
That's broke.
increase in number of protons.
Oh my. I cannot see that. Your Yeti is annoying.
Yeah, your Yeti couple of
That was fine.
Come back here and just chat for me on your observer.
So
You're good.
if it goes left,
So
it will
decrease the
increase because it decreases.
Yes. It'll do the verse. It'll do the vice versa of it. It'll flip.
So when protons increase, the row decreases. Maybe that.
Is that an 80 plus?
If you increase the number of protons, you will decrease the size of the atom.
This are going way over my head.
That's because you're sitting back there laughing.
No, I'm playing.
PT proton.
This is why we have 10 left. Here you go. Let's look this video.
Why? You're paying such well attention. You don't need it.
But I don't understand it.
Okay.
What's on the quiz again? One more time.
What?
Huh?
What is it?
What's on the quiz?
Which quiz?
All of them. Lay it out.
Everything.
Everything we've
That's
ever learned
junk.
in our whole entire life.
I can barely remember my last name.
was president.
All right. In this ionization energy, ionization energy has a trend. So this is the thing with ionization energy. It's all about the energy needed to remove an electron from a neutral atom. So this is the case. As you go up the periodic table, so you go up a column, ionization energy I'm being very nice. I have never had to move a kid in chemistry ever in my life.
I'm clearly paying attention.
You are pushing the bounds today.
attention.
As you go up the column, ionization energy will increase.
So basically,
So
the
if it's
atomic
down, it
radius
decreases,
is
right?
just the opposite. Is this under ionization?
No, don't look at it like that. They're their own thing. Keep them separate. Don't try and think of that.
On this one, will it be if you go down, it decreases?
Yes. So in this case, let's take, for an example, so you guys can get this, lithium, which is atomic number 3, and cesium, which is atomic number 55. And think to this. How many energy levels are being used? So how many energy levels are there in lithium? Don't somebody scream 3 to me. That's how many protons are there. 2 energy levels. How do you know it's 2 energy levels?
What's the first energy level coming up to? You know that.
What?
Bravo, you went through the second way of figuring it out. It's in the second row. Great answer, huh? Cesium, how many energy levels is cesium using?
Where's that at?
Principal quantum number, N. If you want an N for cesium, what is it?
6.
6.
Oh, 1, 2,
So in this
3,
case,
4, 5, 6.
look at it this way.
Praise
1, 2, 3, 4, 5, 6. Alright. As you're walking out, I'm still putting this on a video. I'm still submitting. So, lithium's outer electron is in second energy level, sitting here.
Will you just make, you have me scheduled 7.
Cesium's outer energy level is here at the 6. Which one is closer to the positive charge? The one at the second energy level. So it has the greater attraction. So this one's farther out, has a less attraction. Which one of these are going to be easier to knock off? The one with the less attraction. So it's a whole lot easier to knock cesium's electron off than it is for me to knock lithium's off, just based off of how close they are. within the atom in terms to the protons. So in this, why does it increase as it goes up the column? Electrons are closer to protons as you go up.